So here we are on our last postulate, HL. We've already done the first 4 postulates and just 1 to go. So HL is special because it is only used for right triangles, just like the Pythagorean theorem, only used for right triangles. And the H stands for a word we remember, hypotenuse, and the L stands for leg. So we just review that the hypotenuse is the longest side of the right triangle and the 2 legs are on either side of the right angle. So when you have an HL congruency, you have the right angle symbol, you have a pair of legs, and you have the H, the hypotenuse. Or you could have the hypotenuse, the right angle symbol, and the opposite pair of legs. Either way is HL. So that's really it, and you've learned all 5 now. So here's the review. Love this chart because it shows you all the different postulates. The side, side, side picture, side, angle, side. Here's our new one for right triangles only, angle, side, angle, and angle, angle, side. So then our problems are really exactly the same, where they give us a picture and we say which postulate is it. Now we just have one extra choice, which is the HL. So if we look at the first one, it's going to be our new one, HL. It's got the right angle symbol, it's got the pair of legs, and it's got the hypotenuse. That's what HL looks like. JLK, PRQ. And by this time you should be like, I am good with this. I'll leave the pictures up there. What about number 2 though? Don't fall into the trap of thinking every time it's a right angle that it's automatically HL. That's a right angle, but if you look at the sides, those are the 2 legs. There's no H. That angle, the right angle, is sandwiched between the 2 sides. It's side angle side, NQP. Don't forget about free sides here. So this is one of our old standbys, angle, side, angle with the free side. If I say SPR, that's going to go with QRP. Free side again in number 4. Which postulate's that one though? It's a right triangle. It's got the right angle symbol. It's got the H's here. And then the L is the free side, so that's another HL, another of our new ones. BAC, CDB. Few more. What about number 5? Let's scroll up now. What about number 5? You're right, this is a none. There is no side-side angle postulate. It's not side angle side because the angle's not sandwiched between the 2 sides. It's not HL because it's not a right angle. This one's an old standby, side, 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 DFE, ACB. And here another one with a right angle that's not HL. This one is, you are right, angle, angle, side, ABC, HJK. And then for good measure, one last HL. The free side there was the H. We were given the right angles and we were given the pair of legs. So PSR is going to go with RQP. Just like before, we're going to have some problems where they give us some information that we mark on the picture. Don't forget. Angle B, angle N are right angles, and then it wants HL. So what's missing is the H. The CA congruent to the OM. That's what's missing. Here they're giving me just that it's right angles, and this is again going to be one of those 2 solution things where in order to have HL I need a leg and a hypotenuse, or I could have this leg and the hypotenuse. So I could either say leg BC congruent to NO and hypotenuse CA congruent to OM. Or I could take legs on the bottom BANM and then hypotenuse CAOM. And I know that's a lot of writing there. Almost done. We're going to revisit what we learned in the beginning of corresponding parts of congruent triangles are congruent. And these we call big, little, both questions. Because CPC-TC is used after we do side, 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 or side, angle, side, or angle, side, angle. After we've shown the triangles are congruent, then we know the extra pieces, or the extra pairs of angles, extra pairs of sides are congruent. Now there's not a lot of room here. On our homeworks we'll be able to draw these separately, but I'm going to show you what I mean by the big triangles. The big triangles, I guess I'm doing the big ones first, are triangle ABC, which is congruent to triangle DCB. Those two big triangles are congruent. They share this side at the bottom, and they're congruent. The little triangles are this little bow tie inside here. So I'm going to do those in purple. So the little triangles would be like triangle AXB is congruent to triangle DXC. And they're going to give you either a pair of sides or a pair of angles, and you have to say, is it in the little triangles, is it in the big triangles, or is it in both triangles? So the first pair is angle 1 and angle 2. Do you agree that those are in the little triangles? And we've just streamlined this for you. We could have made you say it's in triangle AXB, which is congruent to triangle DXC, but we're just going to say it's in the little ones. How about angles 3 and 4? Yep, 3 and 4 are in the big triangles, and you can even go back and outline them so you can see how they're in the big triangles. 3-letter angle ABC, ABC, and DCB, that's also in the big. And you might say, well, what does it look like if it's in both? That would be like angle A and angle D. You could tell by the picture it's both purple and green. That's in both. Same thing with AB and DC. That's in both. BX and CX, which ones are those in? Yep, those are the little. And then two more, ACDB. Which are those in? ACDB. Yep, those are the big. And then the last one is AX and DX. And you're right that that's in the little. Now on the homework we'll have you separate those triangles, draw them out. It'll make it a little bit easier, but colors also make this problem easier. Big, little, both. And we learned HL.